children, we can see some numericals. First question, a jet plane starts from rest with an acceleration of 3 meter per second square and makes a run for 35 seconds before taking off. What is the minimum length of the runway and what is the velocity of the jet at takeoff? So first you write the data from the question. So a jet plane starts from rest. So what is the initial velocity? That is 0. So we can write u, that you studied v0. So here we can write the u. Okay, u equal to 0 with an acceleration of 3 meter per second square. So a equal to 3 meter per second square and makes a run for 35 seconds. So that is the time. That is 35 seconds before taking off. So the first part, what is the minimum length of the runway? So minimum length of the runway means the distance travelled by the jet plane. That is noted as x or s. So we can write minimum length of runway. Okay, minimum length of the runway s equal to, that is distance travelled by the jet plane. So from the equations of motion we can write s equal to ut plus half a t square. Then substitute the values. U equal to 0 into 35 plus half into 3 into 35 the whole square. So when you calculate this, you will get the answer 1837. Okay, 1837.5 meter. So this is the minimum length of the runway. Then second part, what is the velocity of the jet at takeoff? So that is the final velocity. So we can write the formula v equal to u plus at. Okay, so what is the u here? That is 0 plus 3 into 35. So you will get the answer 105 meter per second. So this is the velocity at the takeoff. So using the kinematic equation, we can calculate the minimum length of the runway and velocity of the jet at takeoff. Second question, a bullet traveling with a velocity of 16 meter per second penetrates a tree trunk and comes to rest in 0.4 meter. Find the time taken during the retardation. So retardation means negative acceleration. So here a bullet traveling with a velocity of 16 meter per second. That is the initial velocity, u equal to 16 meter per second. Suppose if the velocity is given in kilometer per hour, you should convert it into meter per second by multiplying it with 5 by 18. Here it is given directly in SI unit meter per second. So we can write u equal to 16 meter per second. And penetrates a tree trunk and comes to rest. So comes to rest, that is final velocity v equal to 0. And in 0.4 meter, that is after travelling a distance of 0.4 meter, a bullet comes to rest. So the distance travelled by the bullet, that is s equal to 0.4 meter. Find the time taken during the retardation. So to find out the time, you can use the formula v equal to u plus at. There you need to calculate the a. So we can calculate the a acceleration, that is the negative acceleration, using the equation v square minus u square equal to 2as. Then we can substitute all the values, that is 0 minus 16 square equal to 2a into 0.4. So a equal to 16 into, that is a minus. So we can write minus 16 into 16 divided by 2 into 0.4. Okay, 2 into 0.4. So the answer is minus 320 meter per second square. So the acceleration is in minus sign. So that is the negative acceleration, that is the retardation. Then we can calculate the time taken during the retardation minus 320 meter per second square. So using the formula V equal to U plus AT, we can rearrange it. T equal to V minus U. Okay, V minus U divided by A. So substitute here, that is V equal to 0 minus 16 divided by minus 320. So by dividing, you will get the answer 0.05 seconds. So this is the time taken during the retardation. Question number 3. A body starting from rest accelerates uniformly along a straight line at the rate of 10 meter per second square for 5 seconds. It moves for 2 seconds with uniform velocity of 50 meter per second. Then it retards uniformly and comes to rest in 3 seconds. Draw velocity time graph of the body and find the total distance travelled by the body. So first you want to draw the VT graph by taking velocity along the y-axis and time along the x-axis. So the question, a body starting from rest accelerates uniformly along a straight line. So for the uniform acceleration, the graph should be a straight line inclined to the time axis. So body starting from rest means velocity is 0 at time t equal to 0 and the nature of the graph is a straight line. So it accelerates uniformly for 5 seconds. Then it moves for 2 seconds with the uniform velocity of 50 meter per second. That is, for the 2 seconds, it moves with the uniform velocity of 50 meter per second. That is up to the 7 seconds. Then it retards uniformly. That means velocity decreases and comes to rest in 3 seconds. That is, at the time 10 seconds, it comes to rest. That is, velocity V equal to 0. So this is the velocity time graph. Then second part, find the total distance travelled by the body. So from the VT graph, you want to find out the total distance travelled by the body. So how to find out the total distance travelled by the body? It is equal to the area under the graph. So we can write distance travelled by the body. Okay, distance travelled by the body. Distance travelled by the body equal to area under the curve. So here area is in the shape of a trapezium. So what is the formula of trapezium? That is half into sum of the parallel sides. So what is the parallel side here? These two are the parallel sides. So we can write half into, what is the distance? This distance, that is 7 minus 5. That is the 2 plus, and what is this distance? That is 0 to 10. So we can write 10 into height. What is the height? 50 meter per second. That is the 50. Then after calculating, we get the answer, that is 300 meter. So this is the distance travelled by the body calculated from the velocity time graph. Fourth question, a train moves from one station to another in 2 hours time. Its speed time graph during the motion is shown in the figure. Determine the maximum acceleration during the journey. Also calculate the distance covered during the time interval from 0.75 to 1 hour. So here the train moves from one station to another in 2 hours time. That is shown in the speed time graph. So you want to calculate the maximum acceleration. Then how will you find out the maximum acceleration from the speed time graph? It is equal to the slope of the graph. So here the maximum acceleration is obtained from the slope BC. So we can write maximum acceleration is equal to slope of BC. So how will you calculate? V2 minus V1 divided by T2 minus T1. So that is equal to 50 minus 20 divided by 1 minus 0.75. So that is equal to 30 by 0.25. Its value is equal to 120 kilometer per hour square. Okay. Then second part, calculate the distance covered during the time interval 0.75 to 1 hour. So the distance covered is equal to area under the graph. So here 1 to 0.75, the area is in the shape of a trapezium. Okay, from 0.75 to 1 hour, the area of the curve, that means it is in the shape of a trapezium. So we can write distance covered. Okay, distance covered from 0.75 hour to 1 hour, that is equal to area of the area under the curve. Okay, area under the curve. So area is in the shape of a trapezium. So that is equal to half into sum of the parallel sides. So what is the parallel side here? These are the two parallel sides. So that is equal to 20 plus 50. Okay, 20 plus 50 into, then what is the height? 1 minus 0.75. So what is 1 minus 0.75? That is equal to 0.25. Okay, 0.25. So its value, when you calculate this one, its value is equal to 8.75 kilometer. So this is the distance covered from 0.75 hour to 1 hour. Fifth question, a race car accelerates on a straight road from rest to a speed of 180 km per hour in 25 seconds. Assuming uniform acceleration of the car throughout, find the distance covered in this time. So, a race car accelerates on a straight road from rest. So, we can write u equal to, initial velocity u equal to 0. Then it attains a speed of 180 km per hour. So, that is v equal to 180 km per hour. So, this change it into meter per second. That is equal to 180 into 5 by 18. So, this value is equal to 50 meter per second in 25 seconds, that is time t equal to 25 seconds. Assuming uniform acceleration is uniform of the car throughout, find the distance covered in this time. So, what is the formula to calculate the distance? That is s equal to ut plus half at square. So, a is not given in the question. So, from the formula we can find out the a. So, a equal to v minus u by t. From the formula v equal to u plus at. So, that is equal to 50. Okay, v 50 minus 0 divided by 25. So, that is equal to 2 meter per second square. Then find the distance. So, what is the formula of distance? S equal to ut plus half a t square. So, u equal to 0 into t 25 plus half into 2 into 25 square. So, we get the answer 625 meter. Okay, 625 meter. That is the distance covered in time 25 seconds. So, here you convert kilometer per hour into meter per second by multiplying the value with 5 by 18. Okay. Acceleration due to gravity and free fall. When a body released near the surface of the earth is accelerated downward under the influence of force of gravity. In the absence of air resistance, all bodies fall with the same acceleration near the surface of earth. This motion of body falling towards the earth from a small height h is called free fall. The acceleration with which a body falls is called acceleration due to gravity and is denoted by g. Near the surface of the earth, g equal to 9.8 meter per second square. You see that motion is in negative y direction and we choose upward direction as positive. Since the acceleration is always downward, that is in negative direction, so g equal to minus 9.8 meter per second square. AT graph for free fall. Free fall is a case of uniform acceleration. So the graph shows that A equal to minus 9.8 meter per second square, that is constant. VT graph for free fall. Velocity changes uniformly with respect to time. XT graph for free fall. Nature of the graph is a curved graph.